The scene you'll be working in is complex and was pieced together using the latest lighting tools and techniques to bring this scene to a commercial-ready state. The following lectures will demonstrate concepts used to create the scene, such as submeshes, emission channels, light mapping, and more. You'll discover how reflections are created, as well as how our environment is dynamically lit using one light source through the use of light probes. You'll gain an understanding of the lighting system and material channels available in Unity, so that you are familiar with the topics and can communicate with industry artists. In this video, I'm going to demonstrate for you how we built elements of this scene. The scene you're looking at here, the final main scene.unity, is a very complex scene that took several hours to piece together. Typically, when you're creating a scene like this, you'll work with an environment artist that will prototype the scene in an outside program, and you'll be able to bring that 3D geometry into Unity and place it wherever you'd like. When you're ready to continue developing, you get to a polish stage where you actually create textures and materials, and you apply those to the geometry in Unity. So if you're ready, hop into the Great Fleece folder, open up the game folder, go into scenes, open up the learning path, and select environment start. Double click it to open it. Inside here is a demonstration of how elements in the scene were pieced together. You'll see here in the far left, we have two pillars. If you select the pillar, move your mouse to the scene view and select F key, you'll focus in on it. You can use the scroll wheel to zoom in and out. We have two pillars here. One is just the 3D geometry. It was created in an outside program, brought into Unity, and set up like this. When we were ready to polish it up, the artist then went into Photoshop, created a texture, and basically created some UV mapping that we can wrap to this 3D model using materials. So what we're going to do is we're going to be walking through these little stations that we have set up, and through each station you're going to be designing from the ground up the final product that is seen in the main scene. So let's start on this first pillar. What makes up this pillar? So if you select the pillars, it's called pillar-start. You'll see here that we have a couple things on this object. We have a transform, we have a mesh filter, which is the 3D geometry. We have a mesh renderer, which allows you to attach a material, which we have right now just a plain material attached. And on there is the standard shader. Every material that you create is going to have, by default, what's known as the standard shader. And there's a few properties on the standard shader that we can play with, such as the albedo channel. So if you select your pillar start, and you open up this gray box on the albedo channel, this is a color picker tool. If I want to make this pillar red, all I can do is just drag it to the red. If I want to make it a different color, I can change the hue and get a color that I like. You can also select a certain pixel by using this color picker pen. And you can select a random pixel and then you'll get that color. Now, albedo channels, and just as your color channel, isn't enough to get the same result that we have in the main scene. That's because an outside artist gave us a texture that was designed specifically for this pillar. So you'll see here that if the pillar here has a little square texture next to it, let's set this back to white. So select the gray little black box here now, and move it all back to white. Next to the albedo text, there's a little circle with a dot in it. Select that, and we can choose a texture to apply to this material. Search for black, and you'll see here that there's a black marble texture. Select the one underneath none. Instantly, you'll notice that this texture is wrapped around the pillar, and we already have a pretty good looking design of our pillar. Now you'll notice that the texturing and the lines are very broad on our pillar start compared to the pillar. That's because we have what's known as tiling. If you select your pillar start, and if you look at your shader, and this is your shader here, you'll notice that if we scroll down here, we have tiling. If you set this to 4x4, you'll see that now you have a more consistent look with your black pillar. Now you might be wondering, why is our pillar not the same color as the completed one? And that's where we get into two properties that are attached to the standard shader, known as metallic and smoothness. Metallic is how glossy your image is, how metallic it is. It gives it a metal look. So what you can do is you can set this all the way to 1, and you'll see here it's pretty similar to the final one. And then we also have smoothness, which is basically how rough is this image. If you set it to 0, there's no smoothness, but if you set it all the way to 1, you can see that there's kind of you can see like light reflection on it. So it's basically just how smooth it is, and then this one is basically how glossy it is. So what I would like you to do is go ahead and set it to about a 0.81, and the smoothness I'd say about to a 0.6. And as you can see, it looks pretty good. Now, to get the exact look of this pillar, if you look on it, you'll notice that we're using a standard roughness setup. And basically, there's 3 standard shaders that come with Unity. You have a standard roughness setup, and a standard specular setup. All we did was we added a standard roughness, which allows you to basically add additional, it's just set up to have rough material. And you can see here that now we have a pretty good looking pillar that looks very identical to what we're using in the main scene. So that's a brief overview of the standard shader, the albedo channel, applying a texture to the albedo channel, and working with the metallic, roughness, and tiling properties. In the next video, we're going to look at these columns here and see how we created those. In this video, we're going to look at how these columns were created. We have 2 columns, column-start and column. What's unique about these 3D models is that they were designed in an outside program to accept multiple materials. You'll notice that this column here has 3 materials. We have the black marble on it, we have a gold piece in the center, and then we have a white border. This is 3 materials, which 2 of them are shared on one geometry, and these are called submeshes. If you actually select the column start, you'll notice that our material has 2 sizes. It accepts one material, which is mapped to the black, and then one material which is mapped to the white. And again, these are called submeshes, and they were created by the outside 3D modeling program to accept 2 different materials to be able to create a unique design like this. The diamond in the center is also a separate material, which we just stuck in the center and made it gold. Okay, so let's look at how we're going to actually create this pillar from scratch. So you'll see here in our column start that we have 2 submaterials, plane 1 and plane 2. Now, one of the materials is going to be the same black marble that we used for our first pillar. So on column start, we can create a new material. So if you open up your learning path, you'll have a materials folder. Right-click that, create, and let's create a new material. Go ahead and name this black material. We'll call it black_matte for black material. And just like we did for the pillars, we have an albedo channel here. We're not going to touch this. We're going to keep that as it is. We're using the standard shader. We can change it to the standard roughness so that we get the same texture as our pillars. And what we're going to do is we're going to add a texture map. So select the circle with the dot next to the albedo, type in black, and select this black marble. From there, you can change the metallic of this material, and you can see it here in the editor down here in the far right, that the changes you apply here will take effect to the sphere. So go ahead and set this to a nice looking dark. You can add a bit of smoothness to it. So I'm happy with 0.8 and 0.726. When you're ready, take this material, and we are going to select our column start, and we're going to drag black_matte to plane 1, element 0. And you'll see here that it wrapped around that submesh. Now we actually have this in reverse, so we're going to replace that with plane 1. So put plane 1 back there, and we're going to put black_matte in element 1. And you'll see there that the submesh is defined to accept a material just for that column. Now for the white, we have a material called a white wall. So similar concept, we're going to go to materials folder. We're going to right click. We're going to create material and call this white wall. We'll say white wall _matte. And I have caps on. Let's see, white wall and _matte. From here, we're going to keep using the standard shader. We have a texture to use for the albedo channel called white wall, white marble. Just select that. You'll see here, if you want, you can change the metallic to make this more silver looking, but I'm actually going to keep this probably at 0, and then you can add some roughness to it. So I'm going to change the smoothness to about 0.18. From here, select your column start, and put your white wall material inside the element 0. So now that submesh is complete. And you'll see there that we have a nice polished submesh for our white wall and our black material. Now for the gold, all that is a standard channel with a colored albedo channel. So let's go ahead and create another material for the gold. Create, material, and we'll call this gold diamond underscore matte for material. This is using the standard shader as well. And instead of, we don't have a texture map for this, we're just using a gold color. So you can select the color picker, change your hue down to a yellow, and let's go ahead and select a gold looking color. So gold, and actually we could even, let's see here if we can get a gold color. I'd say this is pretty good. When you're happy with your gold selection, select your column start, open it up, and you'll see here we have a gold decor. Change the material in here to be your gold diamond material. Just drag and replace it. And now you see here that we have a gold pillar. Now obviously the artist that created this took a bit more time in picking the colors and got a much more shinier gold look. And you can see that here. So, and also you can see that ours is much brighter, and the reason for that is because on our white material, we have a lot of, we just didn't smooth it out enough. And I believe we can also add some metallicness. So if you increase the metal look of it, you'll get a darker feel just like that. At the end of the day, when you're working with materials, it's all about experimentation. As game developers, it's very important that you can communicate with your artists, and if you're working on your own indie game, it's important to know how to just modify materials to your liking. And that's exactly what I'm demonstrating here for you. In the next section, we're going to look at how we create a transparent window. Next in our list is the windows. So what I want to show you guys is how did we get this window look and feel where we have reflections on the window as well as just overall you can actually see through them, right? So the windows are very unique objects. So very similar to the columns, which were submeshes. They had 2 submeshes. The windows themselves have 4 submeshes. And you can see here on the finished window, we have a wall white material. We have a black marble column, which is the rim here. We have a metal rail. And then we also have a glass material. Now what I want to show you with the glass material is how it's rendered, and we're going to create the glass from scratch, but what I would like to do is drag the white wall, the black marble, and the metal rail all from the initial one. So select the wall, select the window wall start, select the window wall, and we're going to choose element 0 is going to be the white wall. And I believe it is the white wall here. Followed by, we have black marble column. So on element 1, select the circle with a dot. We're looking for black marble column, which is this one here to the right of the none. And then we have the metal rail material. So add the metal rail. And we have a metal rail material. And you can see here that everything looks just as good as the original, or the final one in the main scene. So now how did we get this window? Now you might be thinking, now we have this plane 2 material. You might be thinking, well, let's just add some transparency. So let's say we did that. Say we open up the albedo color channel, and we set the alpha channel to about 0. You'll notice that nothing is really happening to it. Just because it's set to 0 doesn't mean we can actually see through it. So how did we create that material to create glass? And the way we did that was we're going to create a custom material. So right click your material folder, create material, and call this glass underscore material. This glass underscore material is just a standard shader, but the only difference is that the rendering mode is using what's called transparent, and that allows us to see through an object. So change the alpha channel now by opening up the color selection and set the alpha to about 47. I'd say about 47. From here, you can take this glass material and you can go ahead and put that on your 4th submesh, the glass material. And there we go. Now you can see here that we actually have glass and we can actually see through the object. So if we wanted to, we can hop into our glass material here And we can add in even more transparency to get a more realistic feel. And that's how we created these windows. So it's a submesh with a transparent material for the window. So moving on, we have our painting wall here. Now we have two painting walls, and this is where it is now your opportunity to look at the painting wall that's completed and go ahead and try and create the materials required to create something very similar to what we have here on this blank canvas. Don't work on the doors, as the doors have something special and unique that we're going to cover in the next video. But for this challenge, go ahead and create some material channels and go ahead and get this look and feel. Take note that the painting wall start, you have a material for the painting wall that has 3 submeshes. So you're going to have 3 individual materials. And then you're also going to have a painting, which you can select from. You can drop this down. You can choose a texture through the albedo channel, and you'll see here that we have several paintings for you to choose from. All you have to do is simply choose one, and it will select the painting. Now you'll notice that it took the entire environment, and that's because I modified that on one of the submeshes. So go ahead and work out creating each individual material and applying it to this to the submeshes individually and trying to get the same result. It's perfectly fine if you have to look at the finished result, look at the materials, and you can see here it is using a white wall, a black marble, and a metal gold. So go ahead and try and create those materials from scratch, and I'll see you in the challenge review. Welcome to the challenge review, where we're going to go ahead and create our own painting wall similar to the final version. So the first thing I want to do is I want to undo my change to the material that is on literally all of them. So let me just hit Control Z here, just so I can undo this change. Okay, so we have our blank wall here. Now, we know from the artist who created this that there are multiple submeshes. So if you select the painting wall, you'll see here that there's a white wall, a black marble column, and a metal gold. So for the white wall, let's focus on that first. So to create the white wall, we're going to create a new material for the white wall. Create material. We'll call this white wall painting underscore matte. And this is going to have a material channel called white wall. We have a white marble texture. And what we can do here is we can add some metallicness to it. Not a lot, but just a bit. And then we can also smooth it out as much as we want. So make it really rough, about 0.038 and 0.127. Now that I have this, I can select my painting wall, and I'm going to swap in the first submesh, which is the white wall painting material. Drop that in, and you'll see there's our white wall. Okay, so it looks pretty good and bright right now, and we can modify this later. So let's go ahead and do the next one, which is the black marble column. So the black marble column, if we remember, is rough. So we're going to create a new material. Create material. And we'll call this black marble column. And painting. And then underscore matte for material. Alright, so this is going to have a black marble texture for the albedo channel. So we can type in black, select the one under none, like so. We have a little bit, let's go ahead and attach it so that we can then modify it in real time. So if you select our painting wall, let's drag our black marble column painting material into the second one. And you'll see here, this is where the black marble is applied. So how do we get that black metallic look? Very simple. Let's select the black marble. If you select it in the inspector here, we'll actually highlight in the project view where it is. And let's go ahead and increase the metallicness. You'll see here it gets darker. We can also increase the smoothness, or we can decrease the smoothness so that it's more rough. We can add some tiling to make the textures a bit more accurate. So make the tiling about 4x4. And let's go ahead and also change the standard shader to standard roughness. And then let's increase the metallicness. So you'll see here we got pretty dark there. And if you increase the roughness here, we get a roughness tab. You can increase that. And let's also make the tiling 4x4. All right, there we go. I'm actually really happy with this. It doesn't look quite like the original, but it's close enough for my liking. And we might actually be able to, let me see here. If we increase the metallic, that's the shinier it gets. So let's see here. And then the roughness, bring the roughness all the way. I'd say the roughness maybe at like 0.8 is good. Okay, so next let's do the gold material. So if we select back on the original, you'll see here that it's looking for a metal gold material. So let's right click, create material. This is going to be metal underscore gold matte. And to create some gold, all we're going to do is we're going to modify the albedo channel, the color channel. And let's use our color picker to get an accurate gold. So just select it. And we can change the metallicness on it as well in real time once we have it on there. So select our painting wall and drag our gold material that we just created, our metal gold material. Okay, let that render. And let's see where that was added. I do not see where that metal gold material was added, so let's go ahead and select this guy. Our painting wall has a metal gold material. That actually might be very... Oh, okay. It's on the outer rim of this, if you actually see that. So there is a separate material that's going to be for the other parts. So on the outer gold rim, now we have an outer gold rim. So that's perfectly fine. We're going to keep that. Okay, so let's continue on. And we're done with our painting wall. But now we have the painting rim, which is for the painting, as well as the painting itself. So let's do the painting next. So here is plane 3. So we're going to create a new material for this. So inside our learning path here on the materials folder, we're going to right click. We will create a new material. And from here, let's call this painting underscore matte. And we're going to use the albedo texture and we're going to select the painting. Once you have your painting selected, select the 3D geometry. And we're going to update the plane 3 material with our painting material that we just created. Swap that out, and you'll see here we have our painting. There's a gold rim that we can also attach to that. So if we go ahead and we can actually use our gold, we can use the same metal gold matte that we just created, apply that, and you'll see here there is our border. And next is that gold inside the black rim on top. And if we look, we have some 3D geometry that's looking for gold. So for here, we can just select our gold metal as well. So metal gold material, and there we go. So we have a pretty similar look. It's not going to be perfect. Like I said before, we had an artist go in here and spend a lot of time making sure that the color saturation and correction was spot on. But you have the idea. If we really wanted to make it a little bit closer, we could just tone down the wall, so the white wall painting. We can add some metallicness to this to darken it, and we can increase the smoothness. And you'll see here that that looks pretty good. So not perfect, but close enough. So I hope you learned something, and I'll see you in the next video. The next thing we're going to be talking about is this door here and how it was created and what's special about it. So looking on this door, we have two things here. We have a standard shader with an albedo channel with just a texture, and then we have here an occlusion map. Now, the reason why this is so special is because an occlusion map is basically used to provide information about which areas of the 3D model should receive high or low indirect lighting. Essentially what this does is it allows us to create false shadows. So as I decrease the amount from 1, you'll notice here that as I move this, the door is actually receiving and getting shadows. It's very subtle, but if you actually look on the sides, you'll see here that as I increase it between 0 and 1, it's getting these sense of false shadows. And basically what it is when you're creating AAA games like this, you're going to often find that very little attention to details are just the littlest things that really bring your game to life. So here's how we create this from scratch on this door here. We're going to create a new material. It's one material called a door matte. And on here, it's just a standard material. I created a folder. Right click, create material, doormat. And on here, we can go ahead and just select our door. Let's give it our doormat material that we just created, which is right here. And on here, we have a few things that we want to do. We have our doormat texture, which is an albedo texture. So we're going to say door, and you'll see here we have a door texture. You can select any one of these. I'm going to choose this one. And on here, we have our occlusion map, which is going to allow, and as you can see, looking at the difference here, right, it's very tough to tell, but you can see that there's kind of shadows on this one here. So if I actually bring that down to 0, let me see. Try and get this in a noticeable state for you guys. But what's happening here is an occlusion map is like a grayscale image with white indicating areas that should receive full indirect lighting and black indicating no direct lighting. So if we actually look at this map here, you can see here that this is what it looks like. You have black parts of the door that receive no light, and then you have the light parts which should have some light on them. So on the finished product, as we take occlusion culling and move it to, or I'm sorry, not occlusion culling, but as we take the occlusion channel and move it to 1, we are basically telling it to use that map. And as you can see here, we'll add the occlusion map. So you can search for door, and you'll see here's the door texture. And it's set to 1, but you can always modify it. And you can see it's super subtle, but as I'm rotating right now, you can really see it. As you get all the way to 1, it's full shadows. And then as you go all the way to 0, there's no shadows. So essentially, we're just creating false shadows. So that's it for the door, and I'll see you guys in the next video. The next thing we're going to cover is the emissions channel, also known as self-illuminance. So emissions is basically light from an object that isn't using a light source, but it's grabbing light data from a texture or a color. A great example of this is our display case. You may be looking at this display case and thinking that, how is this naturally lit right now? There could be some spotlights in it, there could be some just some sort of light source in it, but actually there is no light source. This is pure emissions. So let's go ahead and look at this display case and click on the display case wood, and let's see how this is self-illuminating. So we look on the material here and we see a standard shader. We have the albedo channel with a texture map and an albedo color, just black. We have some metallicness, so the higher the metallic, the more reflective it is. We have some smoothness going on. We have a normal map. Now, normal map is basically a detail map. It just adds extra detail to the wood. We have an occlusion map, so we're creating false shadows around this cabinet. And then here we have an emissions, which we can control the value here. And then we also have an emissions color map. So if we control this value, you can see here that we can actually greatly increase the illuminance coming from this cabinet. Now let's go ahead and remove this texture by selecting the circle with a dot. If you remove the texture by selecting none, you'll notice here that with a value of 1.94 at the illuminance or the emissions, and if I increase it, it's just white light. So basically what's happening here is it's self-illuminating, and it's basically without a light source, we can create light in our scene. So let's look at how it's being controlled. So if I actually bring this all the way down, we can control the light. So we can make it very soft, and you'll see here, and if it goes to 0, then we have 0 emissions. So how is it that that texture map is able to illuminate this casing properly? The way it works is that texture map, if we open that up, it's this display case wood surface color. If we take a look at this, in an outside 3D modeling program, this light in this cabinet was baked so that Unity could read data on where to illuminate light. So you can see here that on the rim of the cage or the case, we want to illuminate light, as well as on the bottom of the casing, we want to illuminate light. So basically what's happening is Unity is able to read this color map, and it's pulling in where to emit light. So if we add that back, so select the case, display case wood, choose color, and let's go ahead and add that back So we're looking for display case wood surface underscore color. And you'll see here that by adding it back, the only places that are emitting light is the top rims, just like we saw in the texture map, as well as the surface that the objects are laying on. And what we can do is we can increase the emission to make it brighter or softer. So the scene that we're going to be working in the main game, it uses just one light source, a directional light as our sun, and everything else is lit purely through emissions and something called light probes, which we'll get into later. So very performance friendly, very awesome. I'll see you guys in the next video. In this video, I'm going to demonstrate the progressive light mapper for you. So while I was developing this scene and as we were working through these tutorials, you may notice that as I was modifying some objects and moving things around, data was recalculating in terms of light in real time in the scene. Right now my scene is fully baked. However, if I were to take this painting wall here, and if I were to just modify some of its material properties, let's go and just increase some of this stuff, you'll notice here that my scene is rebaking to accommodate that. This is the progressive preview mapper. So there are two forms of baking in Unity. There's the progressive preview, which allows you to bake in real time and see the results very quickly. And then there is the enlighten mode, which means that your scene has to bake before you can actually see any changes. So here's a really good demonstration of this. Let's hop back over to our example over here where we have our light probes. Right now, what I want to do is I want to open up our light settings. So go to Window, Lighting, Settings. Inside here, it's right here next to the inspector panel. Oops, go ahead and position that next to the inspector panel. So in here we have some settings related to lighting, and specifically we have our light mapping settings. Right now I'm in the progressive preview mode, which I just demonstrated allows you to update in your baked maps in real time. Now with that, there's a couple options here. There's something called auto generate, which basically detects those changes and it's going to auto bake your maps. If you turn that off, you're responsible for actually generating your new light data. So check this out. If I switch to enlighten, there's no more progressive preview, which means that in order to see any changes, I have to regenerate the light. Now, in enlighten, you can keep auto-generated on, and it will detect real-time changes. Or what we can do is I'm going to demonstrate here. I'm going to use enlighten, and I'm going to move this self-illuminating material here, which is using our emissions channel. I'm going to move this, and you're going to notice that the light doesn't update, or the light won't update and reflect the scene until after it's finished baking. And then I'll go ahead and show you again in the preview mode using the progressive mapper, and you'll see how insanely awesome the progressive mapper actually is, because it allows for quick iterations. Okay, so right now I am in the enlighten settings. I have auto generate on, and what I'm going to do is I'm going to take this cube here that is self-illuminating using an emissions channel, and I'm going to move it. So I'm just going to move it to the left here. Notice the light data stayed. The box is here, but the light data stayed. And right now, my scene is rebaking. I have 0 changes of how this is going to look. I'm actually going to move this over to here. My scene hasn't updated, but you can see in the bottom right here that it's baking. So until it's finished baking, I will see 0 results of how this is going to look until it's finished. So let's go ahead and let it finish. It's got about 1 job left. This will probably take about 30 seconds. I'm doing a speed time lapse of this baking process, and you're about to see here that it's about to get finished. And as it finishes, you'll notice that the old light data, as soon as it finishes baking, is gone, and now we have the new light data. So check that out. That is using the old enlighten system. Let's look at the same example using the new progressive mapper. So hop back over to our lighting settings and change it from light mapper to enlighten to light mapper progressive preview. Now you'll notice that there's a checkbox here called prioritize view. And what that does is based on what I'm looking at, it's going to prioritize what I'm looking at and bake that information first so that I can go through rapid iterations when developing. So for the same exact example, I'm going to let this bake, and you'll see here that the baking has about 8 seconds left. It's much quicker than Enlighten. I'm going to let this finish baking. I'm going to move it back to this area where the sphere is, and you'll notice how in real time it's going to show those changes. So as I move it here and I drop it, as soon as I drop it, Enlighten is already baking. You can see here, I can already see the reflective surfaces, or I can see the dynamic lighting reflected onto this dynamic object, as well as now I'm baking in real time and I can see where my light is illuminating. Now there's still light data from where it used to be. However, within the next 30 seconds to a minute, that data will be gone. So that is the progressive mapper. It allows you for dynamic changes in your scene and allows you for quick iteration prototyping so that you don't have to wait several minutes to see the results of moving static light. And as you can see, I can move this anywhere and instantly it's going to reflect where it is in the scene. So I can move it back. There you go. So that's the progressive mapper. That's the preview. And I will see you guys in the next video. The next thing we're going to look at are called light probes. So let's head on over to the security desk in the center of the room. We have two objects here. One is the security guard desk, and it's a static object. And there's no light source, but we have these monitors that are glowing, and that is from the emissions channel. So we have some self-illuminance there. And then also we have this little square here, which is basically acting as just a light source without a light source, but it's also just an emissions channel, and we've set it to a pretty high limit of 3.791. And then here we have this dynamic object. Now we have no light source, but we're going to have dynamic objects walking around in our game. So what we might want is when an object were to pass one of these light sources, we want to emit that data onto the dynamic object. If I move this sphere left and right, you'll notice that as it walks, it picks up that illuminating channel. Now, the reason for that is because of a light group. And in order for this to work, these objects must be static and these lights must be baked. If I were to move this cube right now, the self-illuminance would stay, but the object would move. Watch this. I can move it, but the light has still stayed because it was baked. Right now, my progressive preview mapper, or my progressive mapper, is rebaking the scene. So let me go ahead and place that back and set this back up to how we just had it. So how did that baked light data get onto my dynamic object? The way it works is we have these things called light groups, or light probes. So here we have a light probe for this specific area. And a light probe is basically just a coordination of lights that are going to pick up baked lighting information and relay it to dynamic objects. So let's go ahead and create something like this from scratch. I'm going to delete this light probe group, and let's create a new one by going to Create, Light, and then we're going to create a light probe group. You'll see here that it's just you'll see here it's below the scene at the moment. Go ahead and bring it up to our security desk. And this is a light probe group. It looks just like a bunch of little dots here, and it allows you to spread where the light data is. So what I'm going to do here is we're going to take these little dots and we're going to stretch them around this area. So here's what we're going to do. Anywhere that we want to acknowledge dynamic appearance and have light data share other information with objects, we're going to put a light probe around it. So to modify this, what I'm going to do is I'm going to click this button here to edit the light probes. And what I can do now is I can select light probes. So I'm going to select this one. I'm going to select that far left one and that one. And what I can do now is I can shift these over a bit. I can duplicate the selected and continue shifting them over. And the goal here is that you want to get a pretty good surrounding area of your lighting. So wherever we're self-illuminating using the emissions, we want to cover that. So let's go ahead and select this one, and let's duplicate this again. And we're just going to get some basic lighting here. We'll duplicate one more time, and we'll put it over here. So what we've done is we've created dynamic lighting that's going to take static baked illuminance information and pass it to our dynamic objects. Now you might be wondering, what more could you possibly do with this? Well, let's hop over to our main scene for just a moment. If we hop over to our main scene, you're going to see that this entirely beautifully stunning scene has just one light source. How is that possible? How is everything in here so well lit, yet we only have one light source? Well, let's go ahead and look at the light probes that make up this level. And just keep in mind, there's only one light probe, and it's across this entire map. And this is it. There are thousands of little light probes that make up this map. And let me find that object again. Here we go. It's the light probe group. As you can see here, there are thousands upon thousands that are all sharing lighting data so that when we have dynamic objects pass through this, they will be illuminated through that baked data. In order to create a level like this, it took hours of work to do. And there's only one light source, and everything in here is being just self-illuminated through emissions, and the data is traveling between this one light probe group. You can imagine how efficient your game can be by eliminating the use of several expensive lights and using a light probe to create dynamic light, especially for mobile. I'll see you guys in the next video. The next thing we're going to create is our skybox. In our main scene, we have a city skyline of New York City surrounded by our entire environment. So what I want to do here is we're going to create a skybox from scratch. So an artist gave us a cube map of a 6-sided cube that basically is the skyline of New York City. So what do we do from here? Well, we're going to hop into our materials folder under our learning path, and we're going to right click, create, and we're going to create a new material, and we're going to create this skybox from scratch. So let's call this, we'll call it New York _ skybox. Okay, so the first thing we need to do is we're not going to be using a standard shader. We're going to be using a skybox shader. If you select skybox, you'll see here that there is a 6-sided option. Select that, and you'll see here that we have 6 textures to fill. If you scroll down into our game assets, you'll notice that we have a skybox folder. So go ahead and select your material, scroll down. Here are the cube maps 0 through 5. You need to populate these cube maps in the respective order to your skybox material. So drag 0 into the first slot, then drag the next one. This is going to be 2, 3, and you can actually see in the inspector in the preview mode that it is building this map in real time as you add the boxes. Okay, so once you've added all those boxes, now we need to actually make use of this skybox. So we created the skybox material. Now how do we actually use it? Well, hop over to our window, lighting, settings, and you'll see here that there is a skybox material. The skybox material we want to use is the New York skybox you just created. Pop that in, and you'll see here that our entire environment is now rebaking, taking in dynamic light or statically baked light from this skybox. And the reason why that's happening is because in our environment here, we have a sun source, which is our directional light, and we have our skybox material. And basically, it's pulling in environment lighting from our source, which is skybox. And this is where you kind of have an interesting option. So right now we're getting natural light from our skybox for our environment, but if we wanted to, we could also just get like a color and have ambient color and just have a red room. But instead, we want the environment lighting to come from our skybox, which is the New York City skyline. And as you can see here, it is constantly rebaking in our preview mode. So that's how you create a skybox and how you apply one. The next thing we're going to be looking at are reflections. So we're going to be taking a look at reflection probes and the new Unity post-processing stack, screen space reflections. So in order to have reflections in our environment, you can already see here that on our marble floor, that our floor has a surface material. They're just using the standard shader, and they have reflective properties that allow the environment and the skybox to already reflect off the floor. But you'll notice that these doors and these big pillars here aren't reflecting in our scene. So what we're going to do is we're going to create what's called a reflection probe, which is going to sample our environment and create reflections around us. So to do that, what we're going to do is we're going to right click our hierarchy. We're going to, or just click in the hierarchy. We're going to go to light and then reflection probe. And what we want to do here is we want to position this in the center or on the end of our floor. So go ahead and drag this up, bring it over here. So this is our reflection probe. It's this little sphere element here that you can see right here. And you can see in the inspector down here that it's already creating a sample of our environment, and it's going to create reflections using this sample. So what we want to do is we want to take our entire floor and we want to create a sample of our marble floor. So we're going to place it here. Let's place it on the ground. So about right there. And what I want to do now is I want to edit it. So there's a little collider setting here. So we can hit this edit bounding volume and we can modify it to take up the length and the width of this marble floor. Go ahead and drag it out and keep going. All right, so what did this do? You can see instantly it's actually created environment reflections. If you look on the floor here, you'll see that these doors and these big pillars here have reflections. And as well as over here, you can see that the pillars are now reflecting off the floor. Now, these are what I would like to call cheap reflections. They're good, but they're not great. And when it comes down to screen space reflections, which I'm about to show you, it is literally night and day. So to demonstrate this, screen space reflections use the post-processing stack. And what we've done is if you click on the main camera, we've created a main profile for you so that you can get the same consistent look and feel as myself when I'm developing this. Watch what happens as soon as I enable this post-processing behavior. This post-processing behavior has screen space reflections enabled. Instantly, night and day, you get accurate reflections and you get stunning reflections. Look at this. Everything is just perfectly reflected as it should. Now it comes down to why would you ever use a reflection probe if it's not efficient to use or if it's just not good, right? It's just not accurate. The way I look at it is reflection probes are cheap. They're cheap reflections and they allow you to have reflections. If you're creating a mobile game, use a reflection probe as you'll get reflections that will pass for your game. If you're working on a game that's for console or for PC and you can actually afford the expense of screen space reflections, obviously use screen space reflections. Screen space reflections is an expensive call, but it's so worth it. As you can see here, I'm going to turn off this reflection probe. And you can see here that screen space reflections is clearly just the way to go. The reflections are just done beautifully for you. So that is screen space reflection, guys. And just real quickly, if you're interested in how that works, we have a post-processing profile here, which we learned about in our previous course. We'll be working with the post-processing profile more in this course, but we wanted to deliver a working profile for you guys. And you can see here that we have screen space reflections enabled, and you can modify some of these settings and mess around with them. But ultimately, everything is done for you when you're working with screen space. All right, I will see you guys in the next video.